All right, so it's time for a quiz. Let's quickly talk about this. Tell me, how is name node failure in non-HA mode tackled? So when we did not have this high availability, how we were handling the failure of the name node? What do you think is the right option? Just go through it and just put your answer in the chat box. Is it A, secondary name node is switched on as a name node, or it's the secondary name node automatically starts working? Or see, like from secondary name node, image backup, primary name node is recreated. So what do you think is the right answer? Okay, so I believe this is still not get. I think this has to be discussed more. So some of you are saying the answer is A. Secondary name node is switched on as a name node. So how can you switch on secondary name node as a name node? And what happens if you do that? Like, will it resolve all your problem? How will it handle the name node failure without high availability? And most of you have given me secondary name node automatically start working as a name node, but we are talking about non-HA mode. So in a non-high availability mode, there is nothing called automatic switch failover. In high availability mode, the passive will become active automatically, but we're talking about non-HA mode. So in a non-HA mode, there is nothing called automatic. No such feature exists at all. Okay. Because there was nothing automatic, that's why they had to come up with the entire new concept of high availability. Okay, if this had been the situation that this automatically becomes name node, that then high availability would not have come at all, right? So see, okay, if you look into all of this option, the only option which is correct is the C. So from the secondary name node, we have to image backup primary name node is created. So secondary name node contains the fs image file, right, which is the updated one, which always gets updated. So we have to get back that image file back, and then we need to create a new name node, because if you make secondary as your name node, then how will secondary work, right? So what they were doing is, if your name node fails, they were getting the image from the secondary name node and getting another name node. That's the right answer. Okay, is there any confusion with it? Do we need a discussion on it? Is this clear to everyone, or still there is some confusion? Okay.
So it will be automatically backed up primary name node, or need to be manually create?
Manually, it was a manual process. That was the biggest pain point, right? It was all manual.
Since non-HA.
Yeah, in Hadoop 1, it was all manual. That's why they had to come up with this automatic feature. Okay, so in Hadoop 1, there was no automatic failover, but in the new version, which is high availability, they have introduced this feature. So now we have automatic failover, right? In non-HA, there was no such feature. Is this clear, or still we have some doubts? Okay.
That's the reason. Non-HA means there is no secondary node, right? Only the one node will be present as a main node.
No. When? I mean, in the current one or in the earlier one?
In the current one.
In the current one, we have still two nodes. One is active as a active, and another is the passive.
Okay.
See, earlier we had primary and the secondary. Now what we have active and the passive. So active and passive are in a high available mode, which means if active goes down, passive will automatically become active. Okay, so that feature is present in high available name node. Earlier, when we had this secondary name node, so there was a manual process to get the image from the secondary name node and then again restore the name node, all of that. Those were all manual process. Okay. In the current version, in the high availability, we have two nodes who are in high available state. So whenever one goes down, another one will automatically become up. Okay. So that's about it. Let's go to the next question and see how it goes. Okay. Which of the following statement best describe how a large 100 GB file is stored in the HDFS? Just go through the options. Is it A? The file is replicated 3 times by default. Each copy is stored in a separate data node. Is it like this? Or is it B? The master copy is stored in a single and the replica are divided into fixed size block which are stored. Or is it C? The file is divided into fixed size block which are stored on multiple data nodes. Just go through the option. Or is it the D? The file is divided into fixed block size which are stored on multiple data node. Each block is replicated 3 times. HDFS guarantee different data blocks. Just read and tell me what you think is the best option out of all four. So the first option, do you think, okay, do you think this is the, so the right answer is D. Okay. All right, very good. So most of you gave me the right answer, which is a very great news. Now let's go to the third question. Which of the following describe how a client read a file from the HDFS? So we have seen the entire anatomy of reading a file. Just go through the option and tell me what is the right option. This is about reading a file. Yeah, so see, the name node will connect to the data node. That is correct. And then it is saying data is transferred from the data node to the name node, and then from name node to the client, which is just opposite of what we discussed yesterday, right? So we said data is not moved to the client. The client moves their program towards the data, or there is no flow of the data happening. The client has to go towards the data. Okay, because your data is used, it is residing on the data nodes, right? So the client, you cannot transfer the data from data nodes to the name node, because name node is one server and data node may be 100 or 1000, right? So if you keep moving data, it will never sustain. Okay, let me go back to that slide. So this is the anatomy of reading a file, right? What we said, the client will be talking to the name node to find the location of the blocks, get the block location. Once you know where your blocks are present, then the read operation will directly talk from the data node, right? So the client is directly reading from the data node. the data is not flowing from data node to the name node. Name node will only give the address where exactly the blocks present. Right?
Okay.
Whoever
Yes,
has to
yes.
read the data, they have to go to the data node and then read it directly from the data node. No flow of the data will happen from here to here. Okay.
So once first and second step will completed, then it's go directly to the data node.
Yeah, the
Third step
client.
for reading.
Yeah, it will directly go to the data node and it will read from them.
Okay. Okay, yeah. I skip this point.
Okay. Which of the following are valid statements? Okay, which of the following are the valid statements? The STFS is optimized for storing a large number of files smaller than the STFS block size. Or STFS has characteristics of supporting a write once, read once. It's saying which of the following are valid. So do you think A is valid? And the second one is saying write once and read once. Third one is saying STFS is a distributed file system that replaces ext3 or external 4. STFS is a distributed file system that runs on top of native OS file system and is well suited for storage of very large data set. Okay, just tell me, what do you think? What is the right answer? Is still having some doubt. So how come client directly know the data block location? So the client will not directly know the data block location, right? So the client will need the help of name node to know the location, right? So the first step is go talk to the name node to find out the block location. After finding them, then go and read it from them. Okay. All right. So I believe most of you gave me the right answer, which is the D option, right? So that's correct. Most of you gave me the right answer. Let's go back to the next one. So name node uses RAM for the following purpose. What do you think is the right answer? Okay. All right, very good. So let's move on. So most of you gave me the right answer. Let's move on to the next question. You need to move a file titled weblog into the HDFS. Okay, you want to move a file. Now, you are not allowed to copy the file. You have ample space on your data node. So what action should you take to relieve this situation and store more files in HDFS? What will you do? Just think about it. Okay, most of you gave me the right answer, which is, and I think there is some confusion also with some of you. Let me talk about it. This question is a little confusing. That is true. Okay. It is recommended to decrease the block size of on your remaining file. So what do they?
I have question. See, once block is defined for the Hadoop ecosystem, so this answer says like we can increase or decrease. Is that possible to increase or decrease without the downtime of the Hadoop ecosystem?
No, that's not possible. So you need a downtime if you change the block size because you restart the services.
Okay.
Okay, so any changes you do to the configuration, you need to restart the services, which needs a downtime.
Maybe you can just explain a little more detail because I believe that C is the right answer, but still I didn't get the exact point what we are trying to ask. See, there is a file on weblog file is available which you want to move within the Hadoop without copying the file, that means without duplicating the file. Is that the one expected here?
Okay. Sorry, 1 second. Let me put everybody on mute. Okay.
Neeraj,
Yes.
as per my understanding, name node is taking care the full responsibility of the replication of the data, right? So if name node is copying and taking the full ownership of the replication, then how block size decreasing should be the solution in this case?
A name node takes care of replication. That is partially true. Okay, see, name node will say replicate the data on these nodes. Okay. I think this this question is not 100% complete. That's why there is so many.
Itself actually is very confusing.
Yeah, this question is not 100% complete. They are saying you are not allowed to copy the file, but what error is coming, that is not mentioned. So I think that's the reason for major confusion. But ideally, see, I believe the intent of this question is like it's saying we have space on the data node. It means data node has the space, but still we are not able to copy the files, right? So one of the reason for this could be like the amount of entries in the name node has adjusted. Okay, it's not to decrease the block size. So it could be something like, let's say, I see this question has some problem, but I will tell you what the concept is. Okay, if you have a file, okay, and you are trying to store that file uh, onto the particular node, okay, or onto a particular HDFS. So it will be splitted into chunks of the data depending upon the block size that we have configured. If it is 128 MB, it will be splitted into smaller pieces of 128 MB. It will be distributed and all. Now, if there is a situation where uh, you have so many entries, like you have adjusted the name node's RAM, because all these entries will go into the name node's RAM, right? Let's say there are some cases where if you have a small files or maybe a small block size, so you will have multiple entries in the name node's RAM. So sometimes what happens, your name node capacity will get adjusted, right? So let's say, for example, this, let's say my name node is having uh, say 128 GB of RAM, for example. Okay, and my FS image and plus edits, the entire entries is all almost 128 GB. It's already completed, which means I have so many entries in the name node. So in this type of situation, if you try to add more files, it means you want to increase even the size of this. Your name node will say that no, I don't have capacity to give some exceptions and all of those type of things. Okay, what, even though you have the space on your HDFS, okay, my HDFS has the space, it can take a lot of the data, but my name node memory is exhausted, which happens very rare, because we are just storing the metadata, right? We are not storing the physical data. But sometimes what happens, even though you have this type of situation, your copy will not be happening. You try to push your file and the name node will crash, it will fail, and it will give some issues or whatever, right? So in this type of situations, what we need to do is we have two options. Either we increase the name node's memory, okay, so most of the time that is a safer to do, considering uh, the other impact, right? So it's always recommended, like if it's possible, you can increase the name node or just try to clean up some unwanted files or merge many small files into one file. So all those things might be required, right? Or perform some sort of what you call it. But in the worst case, what you will do is in this case you might have to increase the block size.